My dear students, we are going to discuss four marks questions and their answers of gravitation. The first question is state Kepler's laws of planetary motion. So Kepler proposed three laws of planetary motion. The first law is known as law of orbits and the second law is known as law of areas and the third law is called law of periods. So what are all these laws? So according to Kepler, all the planets revolve around the sun in elliptical orbits. So this is an ellipse. For ellipse, you will have this is one focus and this is one focus. So out of these two, sun is sitting and this is the planet. It is going around the sun. So this is the first law. All the planets revolve around the sun in elliptical orbit and the sun is situated at one of its foci. That is the first law. So it is dealing with orbit. So it is called law of orbits. Next, what do you mean by law of areas? In 1 month, the line joining the planet. So in 1 month, let us say in the month of June or in some month, this planet moved from this place to this place. The area covered by this planet in the month of June is, let us say, A1. Take another month. In another month, this is the area. So this is the area swept by the line joining the sun and the planet. Let us say this area is A2. So according to Kepler's second law, both these areas are equal. So A1 is equal to A2. So what are these areas? These areas are nothing but the area swept by the line joining the planet and the sun. So how to write the statement? The area swept by the line joining the planet and the sun is same in equal intervals of time. So in equal intervals of time, the area swept by the line or the radius joining the planet and the sun is same. So in equal intervals of time, the radius vector sweeps equal areas. Now, what does the third law say? So this is the elliptical orbit. Here is the sun around which a planet is revolving. The distance between the planet and the sun is changing. Here it is far away. When the planet is here, it is very near. So I will take the average distance. So let us say the average distance is r. The time taken by the planet to go around the sun is t. So this is called period of revolution. So according to law of periods, the square of the period of revolution of the planet is directly proportional to cube of the average distance between the sun and the planet. So here r is the average distance between the sun and the planet. Second question, what is orbital velocity? Obtain an expression for it. What do you mean by orbital velocity? Orbit is, suppose this is the earth around which a satellite is revolving in a circular path. This path is called orbit. The minimum velocity that should be given to a satellite so that it undergoes orbital motion or it undergoes circular motion around the sun is called orbital velocity. The minimum horizontal velocity that must be given to a satellite so that it goes in a circular orbit around the earth is called orbital velocity. So this is the earth. So from the earth, the mass of the earth is m. From the earth, at a distance of r or at a height of h, let us take a circular orbit. The radius of the earth is capital R. So whenever if you want to have circular motion, there must be a force called centripetal force. So whenever there is a centripetal force, then only you will have circular motion. So who is giving centripetal force for this satellite? The centripetal force is given by gravitational force. So this gravitational force acts between the satellite and the earth. Let mass of the satellite be small m, mass of the earth be capital M, the radius of the earth be capital R, the height of the orbit is h. So formula for centripetal force is mv square by r. So I write it as mvo square by r. Vo stands for orbital velocity by r. Here r should be the distance, that is nothing but the radius. Radius from the center of the earth. From here to here r, from here to here h. So mvo square by r plus h. From Newton's universal law of gravitation, the gravity or the gravitational force of attraction is given by gm m by square of the distance between them, that is r plus h whole square. So this and this gets cancelled, small m gets cancelled. So you will end up with vo square is equal to capital G capital M by r plus h. In most of the cases, height of the orbit is very less when compared to the radius of the earth. So when compared to this r value, h value is 0, so h can be neglected. So let us put h is equal to 0. So vo square is equal to gm by r. So this is the expression for the orbital velocity. So if I take square root on both sides, it will become gmr. This can also be written as vo is equal to under root gr. This is obtained from the relation g is equal to gm by r square. In the case of earth, the value of orbital velocity is around 8 km per second. So if next third question, what is escape velocity? Obtain expression for it. Escape means going away. So we have earth. So earth has got gravity, that means it attracts everything. It doesn't leave anything to go away from its gravitational field. So if I throw something up, it goes to certain height and falls. If I increase the speed, the height increases. If I increase further, so it will not come back and fall on the earth or fall on the ground. The velocity with which a stone must be thrown into the space such that it never returns. It goes away from the gravitational field of the earth. It should escape from the gravity of the earth. That velocity is called escape. Escape velocity is the velocity with which an object can escape from the earth's gravity, its attraction. So that is called escape velocity. I indicate escape velocity by VE. So in order to give escape velocity, that means I am giving kinetic energy. So kinetic energy of the escaping object must be equal to the work done by the system. So this work done is nothing but Gm by R. The work done by Gm by R. So this must be equal to half mv square. This is the kinetic energy of the stone or a rocket or a satellite. So mm gets cancelled. So you will get v square is equal to 2gm by r. Or I can write ve, escape velocity, is equal to under root 2gm by r. By using the notation or by using the formula or the relation, by using the relation g is equal to gm by r square, this can be written as ve is equal to under root 2gr. So this is the expression for the escape velocity. Its value is 11.2 km per second. Now the last question of the gravitation. What is a geostationary satellite? Geo means earth. So geo means earth. Stationary means rest. Satellite means something going around the earth. Some artificial object going around the earth is called a satellite. For example, moon is a satellite because it is revolving around the earth. Now geo means earth. Stationary means rest. A satellite cannot be at rest. A satellite always moves. Why it is called rest? Suppose two objects are moving in the same direction with same speed, the relative velocity will be zero. That means for this person appears to be at rest. We both are moving with the same speeds. So when compared with the other's speed, this fellow's speed will be zero. So we both of us feel that we are at rest. We can talk to each other while we are going with the same speed on the two bikes in the same direction. So what do you mean by geostationary satellite? This is the Earth. So Earth goes from west to east. So in the same direction of the spinning of the Earth. So this is the direction of the spinning of the Earth. In the same direction of the spinning of the Earth, I am introducing an orbit in which I am sending a satellite such that it is at a distance of 36,000 kilometers from Earth. So this geostationary orbit is at a height of 36,000 kilometers from the Earth. So I am making the time of revolution of the satellite is also equal to the time of rotation of the Earth. When both are same, for me, for a person standing on the Earth, this satellite appears to be at rest. So when this Earth rotates, by that time, satellite also moves. When it moves, you will come here, you will come here, you will come here. So for a person standing in Hyderabad and looking at the satellite remains at the same position. So what do you mean by geostationary satellite? A satellite which is going in the direction of west to east, number one, parallel to the equator. This is the second one. Third, the satellite is revolving in the circular orbit which is at a height of 36,000 kilometers from the ground. And the fourth one, whose period of revolution is 24 hours. A satellite which is going around the Earth in a circular orbit of radius 36,000, height 36,000 kilometers from the Earth, and whose period of revolution is 24 hours, and it is parallel to the equator, and it is going from west to east, the direction in which the Earth is spinning. For geostationary satellites, period of revolution is equal to 1 day. So that is nothing but the spinning period of the Earth. So why this geostationary satellite is used? If you write 2 or 3 uses, applications are enough. So to study atmosphere or atmospheric layers, atmospheric changes, to study the atmospheric changes. Next, to forecast weather, for forecasting weather. Next, to communicate. So all communication satellites are placed in geostationary orbits. Next, to find out minerals,